Let's talk about reference angles. So a reference angle for an angle is the acute angle formed with the x-axis. So in general, the angle sits somewhere in some quadrant, and you can imagine when you draw a line that makes some angle with the x-axis, and the acute angle that it forms with the x-axis is the reference angle. So let's just sort of get an overview of what that looks like for our different quadrants. So in quadrant 1, the angle formed, so if this is my angle theta, then in that case the reference angle is just itself. So sometimes you'll see theta prime used to notate it, so theta prime or theta r. Those are both notations that are sometimes used to refer to the reference angle for an angle. So in the first quadrant, an angle is its own reference angle. In the second quadrant, so if an angle falls over here, if that is my theta, well, let's look and see, what angle does this form with horizontal? Well, it forms two angles, and the angle that's acute is over here. So this would be my theta prime. That would be my reference angle. Let's see, now in quadrant 3, I come all the way over to here. So this is my angle, my theta. Well, in this case, the angle that this angle forms with the x-axis is right here. That is going to be my theta prime, my reference angle. And finally, in the fourth quadrant, my angle comes down over here. So now my theta goes all the way around to here. What is my theta prime? Well, again, it's just the acute angle formed with the x-axis. So there's my theta prime, is this little angle down here. Okay, so that is a general pattern for how to find a reference angle. You just have to see which quadrant does it lie in, and then figure out what you need to adjust by to get it to a horizontal line. So let's look at a few examples with some real numbers. So let's see what the reference angle for 160 degrees is. If we sketch a quick plot of where 160 degrees is, that's going to be a little bit short of 180 degrees, right? 180 degrees is over here, so 160 degrees lies somewhere over here. And so the reference angle in this case is that little difference there. It's how much difference 160 is from horizontal, which is 20 degrees. So 20 degrees would be the reference angle for 160 degrees. There's another example. Let's find the reference angle for 93 degrees. So for 93 degrees, we are slightly past a vertical line, right? Vertical is 90 degrees. And so we've gone a little bit beyond. We've gone over to here. That's where 93 degrees will be. And so even though we're just a little bit past 90 degrees, the reference angle will still be that acute angle coming up to our angle. So in this case, since 93 is over here, the rest is going to be the difference. It's going to be 180 degrees minus that 93 degrees, which is going to be 87 degrees. So that's our reference angle for 93 degrees. So now we're asked to find the reference angle for 320 degrees. So let's again plot our angle. So remember that 360 degrees is all the way around. So 320 degrees falls a little short of that. And so 320 degrees is going to sit somewhere over here, right? 320 degrees goes all the way around to there. And so again, 360 degrees is over here, so our reference angle is going to be that little bit left over. It's going to be that acute angle formed with our angle and the x-axis. So that's going to be that difference of 40 degrees. So 40 degrees is the reference angle for 320 degrees. Now let's think about reference angles in radians. So with 4 pi over 3 radians, let's think about where that falls, in which quadrant. So remember, in radians, pi is over here. That's half a rotation is pi radians. So 4 pi over 3, that's a little bit more than 1 pi. So 4 pi over 3 lies somewhere over here. That's where 4 pi over 3 is. And so we can figure out that our reference angle is going to be this difference here. It's going to be this acute angle formed between 4 pi over 3 and horizontal. And that difference is going to be 4 pi over 3 minus pi. That's the difference. That's the angle there. That's our reference angle, which is going to be 4 pi over 3 minus 3 pi over 3, which is just pi over 3. So that is our reference angle for 4 pi over 3 radians. Now, what is the reference angle for 11 pi over 6 radians? Well, 11 pi over 6, let's see. Now, 11 pi over 6, that's just a little bit less than 12 pi over 6, which is 2 pi. Remember that all the way around the circle, if we get all the way around, that's 2 pi. So this is going to be a little bit less than 2 pi. So this sits somewhere over here. That's where 11 pi over 6 is. And so our reference angle is going to be that little bit left over, that little difference between a horizontal line and our angle. So in this case, it's going to be 2 pi, the full rotation, minus our little bit left, minus where we ended up, 11 pi over 6. And remember, 2 pi is just 12 pi over 6. So it's 12 pi over 6 minus 11 pi over 6, and that just leaves us with pi over 6. So pi over 6 is our reference angle for 11 pi over 6. Now, we're asked to find the reference angle for 5 pi over 4 radians. So let's think. 5 pi over 4, that's a little bit more than 1 pi. And so, again, pi is half a rotation. Pi sits over here. So 5 pi over 4 comes over to here. It's an extra quarter pi past pi. So this is going to be our 5 pi over 4. And so our reference angle is that extra distance past pi that we went. So our reference angle is going to be 5 pi over 4 minus pi. That difference is our reference angle, which is just pi over 4. So that is our reference angle for 5 pi over 4 radians. Now let's think a little bit about some reference angles in radians when we're not told some fraction of pi that we might be a little bit more familiar with. So for example, what is the reference angle for 4 radians? So we have to think about this a little bit. Well, remember that pi is 1/2 of a full rotation. Pi is over here, and pi is approximately 3.14. Right? So 4 radians is going to go pi plus an extra 0.14 0.86 or so. So so that's our angle 4. And so we want the reference angle for that. Well, it's just going to be that little difference. It's going to be how far past pi 4 goes. Well, how much further than pi is 4? Well, it's 4 minus pi. That would be the exact answer for the reference angle for 4 radians. And we could also get a decimal approximation for it if we were asked for that. But it's good to be able to take a whole number of radians, or any number of radians, and use what we know about pi to figure out approximately what angle or what quadrant that falls in. So now we're asked to find the reference angle for 3 radians. Well, 3 radians is just a little bit less than pi. Right? We know that pi is half a full rotation, and so 3 radians is going to be just a little bit less than pi, somewhere over here. Again, pi is 3.14, so 3 is a little bit less. And so to figure out our reference angle, well, our full angle is here, and the reference angle is that little bit left over, that little bit that it falls short of coming to full pi. So in this case, it'll be pi minus 3. That'll be how much is that little angle there. So roughly 0.14. Now let's think a little bit about some negative angles. So a negative angle is not too much harder than finding the reference angle for a positive angle, but we just need to mention it. So the reference angle for negative 40 degrees, well, let's think about what negative 40 looks like. That's somewhere down here. Negative 40 looks like this. So that is our angle minus 40 degrees. But again, the reference angle is just whatever acute angle is formed by our angle and a horizontal line. So in this case, this angle is our reference angle. That angle is 40 degrees. So 40 degrees is our reference angle for negative 40 degrees. Now we're asked for the reference angle for minus 210 degrees. So minus 210 degrees. Let's think about that. Well, minus 210, well, minus 180 would bring us over to here. So minus 210 goes an extra few degrees past 180. So minus 210 sits over here. And so our reference angle is just that extra little bit that it goes past 180. And so that difference there is going to be just 30 degrees, because minus 180 is there, minus 210 goes a little bit beyond. So 30 degrees is going to be our reference angle there. Alright, now just a little bit trickier. Let's find the reference angle for minus 2 radians. So what does minus 2 look like? Well, minus pi would be a 180 degree, or half a full rotation in the negative direction. So minus 2 radians is going to come up a little bit short of that. It's going to come up somewhere over here. So that's minus 2. And so our reference angle is going to be the difference between those two. It's going to be how far down we have to come from there. And remember, we want an acute angle, and so if we come 2 in this direction and we didn't quite make it to pi, the answer is going to be pi minus 2. That'll be the difference between how far we need to go to horizontal and how far we actually came. So that's going to be the reference angle for minus 2 radians. All right, now finally, we want to find the reference angle for minus 6 radians. So let's think about what that looks like. Remember that if we went minus 2 pi, that would be all the way back to our starting point, but we went minus 6. So let's just remind ourselves 2 pi would be over here if we went all the way around, but 2 pi is roughly 6.28. 2 times 3.14. So minus 6 means that we didn't quite go all the way around. We went a little bit short of all the way around the circle in the negative direction. So somewhere over here is minus 6. And so our reference angle is just that little bit of leftover. It's this little bit here, which is going to be 2 pi. The full rotation would have been minus the 6 that we went. So 2 pi minus 6, which would be roughly 0.28.